Hello and welcome to a Worldviz webinar. It's been a little while since we've done one of these, but we are excited to be back. I hope everybody's excited to be here as well. So I see people are coming in right now. We'll probably give it just a minute here while everyone's joining. But yeah, it's been a little bit since we've done one of these, and we're definitely looking forward to what's going to be a pretty jam-packed hour-long whirlwind tour of everything related to VR lab budgeting. So let's just jump in, because I think that's what we have time for today. We're really going to cram it in there. So I'm just going to get started. So a quick introduction to the presenters. All of us are on screen right now. So first on my view is Seda Rabaudi. He is our product manager for Vizard and SightLab. Those are Worldviz software development tools for VR researchers and professionals. And then we also have our co-founder and CEO Matthias Pusch here on the phone. So Matthias is also joining us. Then my name is Dan. I am the head of sales here at Worldviz. So yeah, we're just going to jump in right now and give you a quick overview of the agenda. So it's a lot to cover today. First, we're going to have a short introduction from Matthias, and then I'm going to jump into different hardware options, the current VR headset market, recommendations for computers, immersive projection systems, and then additional hardware that you might use that's research specific. After that, I'm going to hand it over to Sado, and he's going to actually give us a bit of a deep dive into the software side of things. So how content is generated, how VR experiments might be authored and set up. So we'll actually give you a little bit of a look at how our tool set works there. So there'll be a live demo for you all for about 10 minutes. After that, we'll look finally at some additional considerations. So this is particularly around services like facilities, personnel, training, the kinds of things that you also are going to need to budget for just beyond hardware. Finally, we'll give you some example total budgets just to give you some rough ballparks at different price points. So entry level, mid-level, and then kind of enterprise class setups. Finally, we're going to have a Q&A. So everybody's on mute for the whole presentation, but we will have a Q&A at the end, and our chat is wide open. So please submit your questions. We've got folks, our Belle is in the background, and she's taking our questions and writing them up. So we'll try to get to all your questions at the end. Even if we go over a little bit, we'll try to get them all answered. So yeah, I think we should just jump into it from here. There will be a recording published to YouTube at some point in the future. It might be days, so we recommend sticking around to the very end just so you can get your questions answered. And we also have a short survey that will go out at the very end. So we'd really appreciate it if you answer that for us. So looking forward to your feedback and handing it over to Matthias now.
Hey, everybody. I'm Matthias Pusch, and whoever worked with Worldviz like over the years, most people get to know most of us the one way or the other. So we started Worldviz, me and two co-founders in 2002, and have really been helping like VR labs, academics, and also some industrial customers to leverage VR and use it for research and also for other things like training or like education or very specific use cases, basically. And yeah, the focus was always to make it work. That's basically what Worldviz was started around. It was started around research. Like originally, we came from a research lab, so I was teaching an intro class together with one of my other co-founders. Like he was the main teacher and I was the TA, and that's how I got into that. And we used our own tools, like for teaching our classes and for building our own experiments. I built my own thesis based on the software tool that's still sold to this day. So I can speak from experience that those tools work, and those tools allow you to create experiments as a researcher. And over the years, I think the tools have gotten extremely good at not just allowing to create experiments, but also to make it very, very straightforward. So the idea was always the researcher focuses on their research and really focuses on the questions they want to ask and what answers they need. And we help use the tools that are there in order to achieve those goals. So for a lot of researchers, we also do that on an individual basis. Like, so just so you know, like, so Dan, for example, here has worked with numerous VR labs, and we usually really get very deep in trying to understand what you're trying to actually measure and what you're trying to get out of the technology. And then we go in and we recommend the pieces that would be the best possible pieces to actually achieve those goals. So we're really trying to make that right, like not just choose a random HMD, but choose the HMD, choose the head-mounted display that is best for your research. But anyway, to get back, like we have basically been doing this for over 20 years. We have done it with a lot of universities and also with a bunch of industrial clients. There's some interesting stories to tell. But for you as a researcher, we have a lot of good resources, obviously, for researchers. One thing that's always interesting to look at is the Partners in Science report, which is a non-exclusive report. There's probably not all publications in there that have been published, but we always encourage people to contribute theirs. And there's hundreds, and probably at this point there have been even thousands of things, research like projects done with our tool chain. And it's all online. You can find the Partners in Science online on our webpage and look what other people have been using the tools for, and maybe get inspired and get ideas from that. But anyway, already talked a little too much here on my end. Wish you guys a great webinar, and hopefully we all learn how to really budget correctly for a VR lab that is successful at the end. Handing back over to Dan here. Thanks a lot.
Awesome. Thanks, Matthias. That was great. So I think the first thing we want to do is just kind of get a better idea of our audience. So we're actually going to send a quick poll out right now. So I'm going to go ahead and launch this. Everybody should be able to answer. And this is just a quick question so that we can gauge somewhat your experience with VR, just so that we have a little bit better idea of where our audience is at. This can be really helpful for us. I'm seeing the questions coming in right now, or the responses. So it looks like a lot of folks, we're getting, most people have some experience with it. All right, I'm gonna go ahead and close, and I think I share this, yeah, if I share the response right now, so everybody should see the results. So this is awesome. You know, I mean, and it just goes to prove how much things have changed. Sato and I have both been working with Worldviz for 10 years now, if you can believe that. You know, I remember doing these types of surveys early on in my career here at Worldviz, and you know, it was nobody had ever tried VR before. We were always giving people the first experience they'd ever had with a head-mounted display, and it's really incredible to just see how much this has grown and how many people are experienced with this technology now. So it's great. I think hopefully you all, even though you are familiar with VR, will still find some value in this presentation. So given the audience is pretty informed already, I'm just going to kind of blow through these first opening slides. Basically, in our estimation of what a VR lab is, you know, it could be as simple as a headset and a computer, but it could also be one of these, you know, huge facilities with multi-sided projection systems, multi-user headset systems, classrooms, showrooms, you know, immersive cave style systems for engineering and research. All of these are kind of under the umbrella of VR labs. But at its simplest, you know, a VR lab can really just be a headset and a laptop, right? So we're going to cover that entire gamut today, from the very basic to the more advanced. So these are some of the things that we're going to be asking ourselves as we're going through, you know, how am I making a budget? How am I applying for a grant? What kind of, you know, what kind of research am I trying to do? And what are the resources that I'm going to need for long-term success, right? So these are some of the questions that you're going to want to ask yourself as you're setting up. given everybody's had some experience with VR, I don't think we have to linger too long on what makes a VR system, but just for general information, as this will come up again, basically you got your computer, which is creating the virtual environment. Then you have your display, which is how you actually view your virtual environment. And then you have some level of tracking, right? Contemporary headsets almost all use what we call inside-out tracking, which is illustrated in this kind of awesome graphic here, where the cameras are looking out and bouncing light back to the objects around them. So it actually sees how you move through the space. More traditional systems use what we call outside-in tracking, which is basically fixed calibrated sensors on the outside looking at the headset. So that's really just kind of the three main components of a true virtual reality system: something to create the virtual environment, something to view it, and then a way to move through the virtual space through motion tracking, right? So when we think of a VR space, we really think of VR headsets. Just like cell phones, VR headsets go through basically a pretty regular refresh. iPhone comes out with iPhone 14, 15, 16. Every year there's a new release. It's not quite that rapid with headsets. It's more like every 2 to 3 years a new release comes out. But these are pretty quantum leaps from generation to generation. So right now, we're really focusing on these top 3 headsets. These are our most used, most recommended headsets in the VR space. And I'll just get something out of the way too, pretty quick here, which is Worldviz works really in a PC VR ecosystem. So, there's a lot of, basically every headset has standalone and standalone capabilities, which is Android-based operating system. And then there's also many headsets have PC-based capabilities, so Windows-based. We're really working within the Windows ecosystem. The Meta Quest 3, for example, can run standalone, so it can just basically operate like a cell phone that you put on your face, but then it can also connect to a computer, right? So we're really in the kind of computer mode. And for researchers, that's what we recommend, because you get more computing power when you're connected to a PC, and it's also a much more flexible and easy to use development environment compared to Android. With Android, you have to go through a whole kind of complex process of developing and publishing to the headset. So in general, we think that the PC is a lot easier to get into, and it's also what we use. So right now, in terms of research-based headsets, the Vive Focus Vision is our #1 recommended headset. What's great about this headset is it has an integrated eye tracker. So that's what a lot of our researchers are looking for, just gathering extra data. Eye trackers in general in headsets, not every headset has one built in, but they're basically like a ring of cameras that go around the lenses here, and they track where you're looking in the virtual environment. So the Vive has a very good one. And yeah, this headset was just released, I think, in November or December of 2024. So it's really kind of a brand new entry into the market. And we have some industry connections at HTC who say that this has a 5 to 6 year life cycle. So we're really looking forward to this being kind of the workhorse of research VR labs for the next 4 or 5 years here at least. So this is definitely our recommendation right now. On the other side of the coin here is the Meta Quest 3 and the 3S. So these are kind of the workhorses of the VR industry. I mean, these are incredible headsets. They're retailing for about half the cost of the Vive. The Vive is, $1,000 to $1,300 for the headset, and then of course you also need a computer to go with it. But then the Meta Quest is a standalone device, and it's really targeting the consumer market. So it's priced at an easily attainable $500 for the 3 and $300 for the 3S. I'll just say that Meta makes incredible headsets. We recommend the 3 over the 3S just because it gives you a little bit of a higher resolution. But if you're looking to just get the most bare bones setup, the 3S is a great option as well. Some highlights of this is that it actually has the ability to do color pass-through. This is actually augmented reality capability. So these cameras in the front allow you to see the world around you. It's got excellent hand tracking. I mean, the amount of power that they put in this thing is kind of mind blowing for $500. So if you're bootstrapped and trying to get set up, you could do this. Is an incredible place to start. It does not have eye tracking. However, we are able to extract what we call a gaze point through the telemetry of the headset. So you can still see where a person's looking when you're using our software, basically by calculating the center of their gaze. So this is a great option for researchers just getting started out, or in more of like classroom or multi-user use cases. This is a great way to have multiple people interacting with each other in headsets. And then the last headset that I'll talk about, and then I'll kind of accelerate a little faster here because I realize that we can talk about these topics for a while, is the Vario XR4. This is the kind of peak performance, but it also comes at a much higher price point. I believe it's $16,000 to get the fully unlocked version of this with a perpetual software license. So this is not in the same price bracket as the first two headsets that we looked at, but it definitely is in terms of pound for pound specs, the most powerful headset on the market. It has a 240 hertz sample rate for the eye tracker that's built in. So for folks who are really interested in a high sample rate for their eye tracking, this might be the way that they have to go. It also has far and away the highest resolution per eye. But again, this is definitely in that professional enterprise class of purchase when it comes to headsets. These three headsets are all really readily supported by the Worldviz software. So depending on what you're trying to do, we think probably most people are going to land in that Vive Focus Vision space, but you could go either way, either up to the Vario or down to the Meta Quest. But all three are great options. I mean, we're spoiled for choice in the current market, right? Just to shout out really fast to some of our favorites from the past. Meta Quest Pro was just discontinued in December. It's still widely available. This has been our go-to headset for the last 3 years before the release of the Vive Focus Vision. The Meta Quest Pro was definitely our recommended device. We still use this all the time. We have labs using this everywhere. It's got incredible eye tracking, face tracking, hand tracking. So, if you have one of these headsets around, or you're looking for a good option, the Meta Quest Pro is still a super viable player in the field of research VR headsets. And then going back even further, folks who invested in VR equipment in 2016, 2017, 2018, maybe their labs got a Vive Pro Eye or a Tobii headset, or one of these HP Reverb Omnicept editions. These are also still very viable, very good headsets with eye tracking that are still widely used, and a lot of research papers have been published using these devices. So there's absolutely no problem with using them. The one thing that we will say is the HP Reverb Omnicept is part of the Windows Mixed Reality line of products, and that is actually being phased out by Microsoft. They will no longer be supported going forward with Windows. So you may be running into trouble if you're using a Windows Mixed Reality headset, such as the HP Reverb Omnicept. So might be time to upgrade if that's what you have in your lab. Moving away from headsets again, throw us your questions. We're excited to see what your thoughts are on this. But getting into the rendering computer side of things, similar to cell phones, there's also the graphics cards, which go through annual refreshes, right? So right now we're kind of moving from the NVIDIA 4060, the 4000 series of their GeForce cards, into the 5000 series of the GeForce cards. And basically, it's pretty simple what we recommend for VR headset users, and that's NVIDIA GeForce GPUs. NVIDIA is definitely more of a household name than it was 5 years ago, 6 years ago. But for a long time, in the gaming and VR world, they've been a really well-known entity as making just the best top of the line graphics processing units, or GPUs. And that is the most important by far component of your VR rig. So we recommend 4060 or higher, but basically just get the best NVIDIA GPU that your budget can allow for. I think 4080 is a really good place to land, or now the 5080 that's coming out this year. They have an even higher jump up from there, which is like the 4090 or the 5090. I believe that comes with like a pretty significant price increase. I mean, you're looking at a few $1,000s just for the GPU. So your whole computer could cost in the $8,000 or $9,000 range, and that's a little bit of overkill for VR rendering. You really can get away with that 4070, 4080, sweet spot in the middle there. But if you want something that's really just going to haul for years, get the best that you can afford. That's what we recommend on the GPU. You really can't hurt yourself by having a higher power machine in that regard. For projection systems, which is our kind of next topic after headsets, you need something a little bit different, and that's what they call these ADA or ADA cards. So they used to call these Quadro cards, but these are the basically they're made for AI, but they also are capable of doing this 3D quad buffering rendering that's required for cave applications. And these graphics cards are significantly more expensive. So I was the ADA 6000. That graphics card alone is like $9,000, right? $8,000, $9,000. So you're looking at a pretty serious investment on the computer side when you are going into 3D projection. If you're doing a multi-wall setup, you might even need multiple graphics cards for running multiple projectors. But basically, long story short is the graphics card for projection systems are a little bit more involved. So that leads us into our next topic, which is projection systems, right? So yeah, I think that this is kind of where Worldviz has a little bit of, this is a bit of our wheelhouse, is we have headsets and projection systems, and we'll show you in just a second how we combine those into these kind of, enterprise or classroom style environments. But if you're unfamiliar with projection systems, basically the difference is it's got the same components as a VR system, but rather than having the display be right here, the display is actually all around you on the wall. So here is an example of a person using an immersive projection VR system. And basically it's got a tracking device, just like we showed you at the beginning of the presentation, that attaches to the 3D glasses, and then a navigation wand that also has an accelerometer and a gyroscope in it, so it gives you orientation for the hand. That's just like your hand controllers for any other VR device. So basically, when you're looking through these 3D glasses, the image is being rendered to your perspective. So as you move back and forth, it actually stays stable and gives you that really nice parallax and stereoscopic 3D view into the virtual environment. So I'll just show you what that looks like kind of in action from an over-the-shoulder shot. And I apologize because I realize, I'll just pause really fast. I know sometimes these videos can be really choppy when we're doing over screen share. Unfortunately, that's just the way the technology is, So if you want to watch this smooth video, it's on our YouTube page. But this is one of our co-founders, Andy Beal, interacting with a virtual environment, a projection VR system, or also known as a cave, with the wand and glasses. And basically you can see he's interacting with the 3D space. To us, it looks like the image is moving back and forth, but to Andy, it actually is staying stable, and he's walking back and forth in the space because it's rendering to his perspective with those tracking devices on his eyes. So this is our kind of our most basic projection VR setup, what we call a corner cave or a dual setup. So in terms of budgeting, this type of system is around $75,000, $80,000 all in with your installation, service fee, and all of that. So, obviously we're talking about a much different class of system, a much higher budget. But, if now that we're getting into the facilities, it's just time to start thinking a little bit more in those bigger terms. So here is our other type. So just to come back here really fast, this type of two-sided system with 3D glasses and the tracking device, that's what we call projection VR. Then we have another type of immersive projection system. We call these our Prism immersive theaters. So I'll just show you what that looks like really fast, and I'll highlight the differences for you as well. So the Prism immersive theater basically is, rather than wearing 3D glasses, it's using 360 video. So we'll talk about this in a second, but 360 video is a really accessible, easy to use way of getting VR content. You can just put a camera down, take a spherical video, and then show that in a theater. And these theaters that we build are touch interactive, so it gives you these really cool ways of, immersive touch dynamic presentation capabilities. They're used widely in the medical simulation market. So for nurses, EMTs, basically if you're working with a medical mannequin, having a really kind of immersive stimuli around you. But then it's also used kind of widely in the education market because it just gives you this really dynamic and fun way to engage an audience with immersive content. So these types of systems are a little lower in cost than the projection VR systems because they're not as complex in terms of having super crazy graphics cards and motion tracking and things like that. So a two-sided, three-sided system, you're looking at a similar scope for the two-sided projection VR system. So starting around $75,000, $85,000, right? So that's basically your two types of projection VR. Just when it comes to if this is something that you're trying to get into, there's a bunch of different options, right? In terms of how we can fit these spaces out. So in terms of configuration, as I already mentioned, this two-sided system is pretty common. But then you also have these three-sided, there's an optional floor. As we'll talk about a little later during the facilities portion of the discussion, projection systems are really where facilities become a kind of a crucial question. Because when you have a headset, all you really need is a utility closet. You can just put a laptop and a headset on and you're good to go. But when it comes to projection systems, you're gonna need a little bit more involvement. You're gonna need smooth walls, specific dimensions, specific paint types. So all of that is stuff that we can guide on. But just as a heads up, that's what you're getting into a little bit too when you do projection. So the two-sided again is one of our most common configurations. Three-sided, I would say, is becoming even more common. And then what's cool about these projection systems is that they're ultra scalable, so you can get them even larger and larger. So this is, I think, this system is like 30 feet wide, so 10 meters wide. This one, I believe, is 22 feet wide, 13 feet on the sides. We have multiple projectors blended together to create these super large spaces. We did a system for Yale, the Beam Lab, a few years back, and that system is 40 feet wide, or 40 feet long and 20 feet wide, and it's this complete surround experience. So you can do some pretty exciting things with projection systems. And this is one that we're really excited about right now. This is actually a classroom that we built at LaSalle University outside of Boston. So this is, you can see, it's a classroom with 12 VR headset stations, and then this huge, I think it's like 50-foot wide projection screen that goes all the way across what was previously two classrooms now linked together. And what's pretty cool about this is we can actually now have combined headset and projection. So I'll just pause really fast to kind of explain what's going on here. So basically you have this student who's in a headset and this instructor who's also in a headset over here. They're in a shared virtual environment that is being output onto the large scale display for the audience. So they're interacting with this educational content and this class can follow along. The instructor can show the student how things work. They can hold these, virtual objects in front of them. So it just creates this really kind of incredible and engaging space. So this is something that we're really excited about. When you put a headset on, you're kind of in your own world, but sometimes with these projection systems, you're able to really expand that into this really super engaging audience experience as well. I mean, people love watching other people do VR. So this is a great way of showing a group in a virtual environment. Yeah, I would just recommend on our website, we have this entire VR classroom case study. We go through the entire project, give you a bunch of pictures. I think it's pretty interesting to just see what top of the line project looks like. This was just installed, in like October, November of last year. So it is brand new. So I'd highly recommend checking this out if you're interested in just what a top of the line Worldviz system looks like right now. So yeah, I think that kind of concludes my discussion of projection systems for now. I've gone a little bit over time, so I'm gonna have to kind of fly through the next few slides. We've already talked about tracking. I won't linger on this too much, but again, every consumer headset these days, just about every consumer headset, has built-in tracking. It's these cameras that are looking out at the world. However, these can sometimes be a little bit of a black box. So some researchers actually need what we call a ground truth position system. And that's where you might need a camera system like our PPT system. This is basically an old school outside in system that gives you a calibrated, consistent tracking coordinates over every single experience. This is a little bit of a complex topic because it could be literally its own like 45-minute webinar. So if you're really interested in tracking for whatever reason, if you're measuring distance between a subject and a virtual object, these are all questions that I think are best sort of handled on a case-by-case basis. But the long story short is most people are going to be just fine with the tracking that comes in the headset. Specialty use cases, you will likely need some kind of ground truth positioning system. So that's just something to keep in mind. And those systems, this again is going from consumer to more professional or research grade technology. So you're looking at about $28,000 for one of these, high-end position tracking systems. Now to just kind of blow through things very quickly, these are sort of your classic add-ons for vrlabs and for research use cases. We've already talked about eye tracking. This is just something that is so accessible now. It used to cost $16,000, $17,000 for an eye tracking equipped headset. Now, your $1,200 HTC Vive Focus Vision has eye tracking built in, and it's really excellent. So, in general, unless you're totally bootstrapped or are totally uninterested in eye tracking, we recommend it as a great and low cost add-on for your research setup. After that, now you're starting to get into a little bit more of the esoteric range. But the next most popular would be biofeedback, physiological sensors. We work really closely with a company called Biopack that many people are really familiar with. They're also based out of Santa Barbara, just like Worldviz. So we integrate with their software and hardware super well. We do a lot of actually cross-promotional stuff with them as well. But they're a great resource for getting research grade data acquisition out of their systems, things like pulse, respiration, and they have great insight as to what these markers indicate about a subject's experience. So when you combine eye tracking and physio, you get really rich detail about what a subject is experiencing when they're exposed to virtual stimuli. So down in the haptic mocap data gloves realm, now you're getting into some pretty serious, very niche stuff. Haptic devices, this is things like surgery simulators. They can be very expensive, like force feedback in general. You're looking at like $50,000 plus. There's some kind of like Tesla suits, things like that give you force feedback on your body. All of that is pretty, use case specific. You definitely want to have a pretty good reason for employing a haptic device because they can sometimes be somewhat complex and costly, and maybe not exactly what you think, right? It's really hard to replicate, the feeling of grabbing something, right? Mocap, again, this is also something that's highly specific. It's used widely in kinesiology and studying human motion, right? So if you really need kinematic data on how a person's moving, then you will need a mocap system, right? There are lower cost options for tracking a whole person's body. Vive makes some really great add-ons that are affordable for tracking feet and hands and things like that. But mocap systems are what you need for more scientifically accurate full body tracking. And it's also used for VR production if you want to create like avatars, if you want to have human actors. But again, these are specialty systems and really start at kind of the low end around $20,000, but are typically more like $50,000, right? And if you're interested in mocap, we have a ton of experience with it. We can absolutely talk you through the options in the market, inertial, marker-based, and then now this kind of emerging class of AI-based mocap that's really exciting. And then finally, data gloves. So this is kind of a popular and iconic VR component. A lot of Worldviz marketing and just general, VR, I guess, hype has been around the putting the glove on and being able to grab something in the virtual environment. And truth be told, the hand tracking that's equipped in these headsets is incredible these days. So it's actually, there are still definitely use cases for reaching and grabbing with gloves, right? But a lot of times, you're going to get away with just like with the eye tracking now and the motion tracking, the built-in sensors for the headsets are quite good. But again, data gloves are still something that's widely used in research for specific use cases, such as reaching and grabbing objects. A lot of people do these types of reaching and grabbing studies, right? And that might be where you need a data glove. This is just a little bit more about BioPack, the systems that we recommend in general. Again, this is a whole topic unto itself, so I'll just keep it going. And then this is our last topic on the VR hardware side, and this is basically in terms of a low cost, high value item. Getting a 360 camera for your VR lab, we think, is just kind of a no-brainer these days. You can get this Insta360 X4 device right here. It's capable of capturing 8K video and is less than $500. You will need some kind of specialized tripod to go with it. But as we're going to see, because when I hand it over to Sato, he's going to show you how 360 video actually works in our software. This is an incredibly powerful and easy way to get VR content and actually start gathering data on your VR environments, because you can just get a student and just boop, pop it down, capture environment, and then tag objects in that space, take eye tracking data on those objects. It's a really fast and easy way to create really rich VR content. Of course, the limitation is that it's kind of like a fishbowl, right? And there are some rules and best practices for how to use 360 video. Again, a whole deep dive topic that we're happy to talk to you all about. But in general, if you're budgeting for a VR lab, I just say throw $500 in there for your Insta360 XR because X4, because it's gonna definitely give you a lot of mileage for your money. So now, as we kind of transition into the software portion of our presentation, let me go ahead. I'm gonna send out our second poll. We're interested to know, and this will kind of help us target our next section a little bit to basically, speak to our audience. So I'm seeing the results pouring in now, and we're overwhelmingly in the academic research and education. I'm trying to see, we got 55% voted. That's actually great. So I'll close this out in just a second. I think we got everybody who's going to vote. So I'll go ahead and share this. So we got a little bit of architecture, engineering, and construction. That's great to see. Definitely in that projection VR kind of cave space. But then overwhelmingly, and I think that makes sense given our bona fides and our audience in general, this is a mostly academic research and education market. So I'll just really quickly kind of speak at a high level to what our software tools are, and then I'll hand it over to Sato. So far we've talked about the hardware, which is kind of, in a lot of ways, the fun part of getting your lab together, building your space. But really where your vast majority of your time and effort and budget and, I think thinking is all going to be is right here in the software, right? And in the software world for VR, there's oh, I gotta hide my poll. In the software world for VR, there's two really kind of main paths that we see, right? On the one hand, you can go down the game engine path, right? And that's tools like Unity and Unreal. And then on the other side, you can go down a more scientific engine or a specific VR engine, and that's where our software tools, Vizard and SightLab, fit in. So Unity and Unreal are incredible tools, right? The analogy I always use is that Pokemon Go is built in Unity and Fortnite was built in Unreal, right? We're talking, 20 million active users every day for both of those softwares, right? So, they're incredibly powerful tools, right? But the problem that we see is that many researchers, they want to get into VR, they want to do VR research. Their grad students are gung-ho about creating a VR experiment. So they say, oh, I'll go get Unity, I'll go get Unreal. And then they find out a year later that rather than doing psychology research, they were actually becoming game developers, because these are complex tools. It takes a lot of time and a lot of expertise to pull a simple VR experience together in a tool that's built for full-blown AAA video game development, right? So while it can be very fun, and intriguing for people to explore career options in game development, it doesn't necessarily get you experiments or research results very quickly. And that's where we think we offer a little bit of a different path, and that's with our Vizard software. So Vizard and SightLab, as Sato's about to show you, is really focused on research use cases. And we just want folks to be up and running, gathering data on virtual stimuli, virtual environments, basically immediately out of the box. So we'll show you how you can just drop 360 videos in, drop 3D models in, and immediately gather data. And one of the coolest things about what our software does is it actually synchronizes data collection across all these different sources that we've been talking about today. So, physio, mocap, eye tracking, motion tracking. What Vizard and SightLab do is it actually gives you this really incredible synchronization for the data and the raw data output of all of those different sensors. So it really lends itself to research use cases. Just from a pricing and budgeting perspective, the Worldviz Vizard software starts around $4,000 for a perpetual academic license. We do have lower cost time limited licenses that are more in the $2,000 range. But you're looking at a little bit more of an upfront investment for a more scientific based engine like Vizard. And then our SightLab software is a little bit additional on top of that. It's about $2,500 depending on if you want a single user or a multi-user license. So without further ado, I'm going to go ahead and hand it over to Sato now. Sato, why don't I just send this your way? Here we go. Oops. I clicked no instead of yes. There we go. I think you should have power now, Sato. Got it.
Yeah, so you could see my screen, you could hear me?
Yep, we got you.
Yeah. Yeah, so as Dan was mentioning, so this is our software tool right here that this can allow for setting up VR experiments, either just using no code or with some Python code. So right now I'm just going to show the no code solution, and then I'll show a little bit of the code. And this could also be from very simple stimuli presentation to very complex experiments. And so our software tools are very scalable in that way, and also very simple. People are always surprised at how easy it is when they think it's a very difficult task just for getting started with setting up a VR experiment, especially with using eye tracking and collecting all the data and synchronizing it. And so just to show you really quickly how to get started. So there's a lot of places that you can gather assets. So we like to use things like Sketchfab as a really good content library where you could get lots of models, or you could use things like Blender, or nowadays you could even use AI tools for either from an image or a text prompt create 3D models, and those are getting really good, or for creating 360 images. And we also have a lot of environments and assets that we've already kind of pre-prepared too, that we just allow with our asset browser that you could download. And so I could quickly show you if I open up this model, which is one of the ones I kind of got off of Sketchfab, and I could now just drag this model into my scene here. And now I'm inside this apartment. So this is a model that I could use. And now if I wanted to go and make a little bit of modifications, our software comes with this 3D editor tool, so you could go and set up things so like where you're going to start in the scene, or if you want to add new objects or collect data on specific parts of the scene. So for instance, this is another object that I just got off of Sketchfab, and I can just click and drag this in here, and now I have just what you would expect from a standard 3D model editor, where I can move objects around, and now I can automatically be able to collect things like view counts, dwell time, fixations, interactions, grabbing events, all of that just out of the box on this object that I've grabbed. And I could also, if I wanted to, go and say I want to measure data on a particular thing that's already part of the scene, I could go and add this region of interest tool, and now I could scale this a little bit. So I'm just going to really quickly kind of scale it over this table, and then you can go and give it a name, so that will show up in the data files. And then if I save this, now I could go back into my software here, and now I have these tools, these objects available. And now I could say, if I want to just use the no code solution and I want to just grab this chair, I could just click this checkbox. I could select which objects in the scene I want to collect additional data on. So these are some objects of interest that I have. And so now I could also go and say I want to generate another trial. And on this one, I want to go and actually show just some 360 media that I've already added. So we could have 360 videos that we could add, or 360 images. And in this 360 image, now I could go and tag some things that I might be interested in, and I could scale this or move these around and give this a name. So now this is going to allow me to collect some data on some objects that are in this 360 scene. And this can also be done with videos as well, so you can do moving regions of interest. And if I wanted to, I could give this a label if I wanted to save something into the data file that allows me to show which, maybe I'm modifying a specific variable. And I could also change, like, do I want to just have these go through in a timer, like certain durations that I want to view these stimuli, or do I want to control it with a key press or an event? I'm just going to keep it with the key press, and I'm going to click done. And now I could also go and modify things, like if I'm going to randomize, or if I want to modify like my avatar. So we have all of this, by the way, will work multi-user, so you can add custom avatars and be able to, with people on the same network or even other remote networks, you could come in and have different participants in the same session also collecting data. And this is where I could set some eye tracking thresholds, like for fixations and dwell time. And I could also go and now synchronize with the BioPack Acknowledge software. If you're running that, just with one checkbox, now I can synchronize things to look at, like what was someone's average heart rate, or what was their skin conductance, or any device you have connected through Acknowledge, and it's synchronized with the scene. And so I'm just going to click continue, and I'm just going to run this on desktop mode, because I don't have a headset connected right now. But you could go and select from things like the Vive Focus Vision or Vive trackers, or all the different supported devices. And as we mentioned with the videos, it's important to note that when I'm showing this, it may look choppy to you because the streaming over GoToWebinar, but it's not choppy when you run it yourself. And now I'm moving around, and it may or may not look choppy to you, but now I could go and say I want to interact with this chair, and I can move that around. We could also do that with physics. And now it's in real time showing that I'm looking at this table, or I'm looking at this chair, and it's collecting view counts, and I'm able to generate walk paths and scan paths and heat maps and everything as I'm looking around in the scene. And the same with the 360 media. Now it's saying I'm looking at the tire and looking over there at me wearing a white shirt. It's not common, but, and now after that's done, I could actually go to my folder, and now I could run this interactive replay where you could view this either in a headset or in the desktop. I could view now everything that the participant did, all of their interactions with the visualizations. And so now I could replay this, and now you could see there's heat maps. I could pause this, I could move around, or I could scrub through, and I could change the intensity or turn on and off any of these visualizations. So for instance, if I want to toggle off like the scan path, and then I could scrub through, and then you could see also this walk path is going to show the direction and the velocity that somebody was moving. Or I could scale some of these, and then I could also go into the 360 session here, this scene, and now I could do the same thing with the heat map overlays and the scan path of where did I look around in that scene. And then I could, in addition to looking at this data, I could also open up the data folder and look at the raw data. And this is all out of the box, so this is without writing even one single line of code. I can look now at all of the included data, and this is also very customizable really easily. You can add just with one line. You could say I want to add a different tracking that you're looking at in the software, but this is, if you were wearing the eye tracked headset, this would be like the individual eye position, the combined eye position, the head position, things like the convergence of the eyes, and maybe if you have pupil diameter and eye openness with like the bifocus vision, you'll have that, and then you'll have like the fixation and saccade values, which right now with the desktop, that's just the mouse velocity, but then you would have the saccade amplitude and velocity, and then you have these flags that will show you when did you look at these different objects, when did you grab these objects, and then since I'm also right now just running the sample data with Acknowledge, I can also look at the same data here and Acknowledge that this is synchronized with the sample EEG, and I could also bring a video replay back into Acknowledge and scrub through and see the physio data as well. And this is the trial tracking data folder. I can also look at a timeline of what were the different things that somebody looked at what time, what was the total dwell time, the number of fixations while in dwell, and then I could go and also view kind of a summary. And so I could look at what are all the objects in the scene that I looked at. And this is also where if you added a label, like you had a specific condition, you could parse through this file, and you could do some data analysis, which we have as well for looking at how an independent variable might change a dependent measure. So you have this data. And so this is kind of like a really quick sort of overview of just looking at some stimuli and how you can just easily look at some data. And then I could also show, so if I go over to the browser here, so we have a whole bunch of different tools and additional like templates that you can use with the software. So things like AI agents, and maybe you want to do biofeedback and see how like you can change something in the scene from the physio data. We have things like the ability to record data from an external like software. So if you're using like a Steam VR game, or if you are using Unity or Unreal, we can also collect the sensor data like eye tracking and visualize a gaze point and synchronize that also with the physio data and things like that. And things like upper body tracking. There's a whole bunch of stuff to look through, like augmented reality, sample experiments, like if you're doing distance perception or a lot of visual search tasks, reaction time. So it's kind of just a lot that you can explore and get started with. Or if you're looking at just presenting phobia, we have things like the fear of heights or like elevator or arachnophobia. There's a lot of things that are just built in that you could just leverage right out of the box. And then also looking at the code, it's really not a lot of code, just if you're familiar at all with just any kind of like Python coding. I would say even someone that doesn't even know Python, it's really easy to get started because it has the autocomplete. You can see really easily how you can access the different methods that are available, and you could look at things like if you're doing gaze events, there's just a simple callback. And then we also provide you with a custom GPT assistant. So I could say, how do I do a gaze-based interaction in SightLab? So this is in regards to the visitor in SightLab that you can now really easily, you probably have already been familiar with using AI for coding, but this is trained on the software and the code itself. So it's going to give you something right out of the box that's very likely going to work, and also give you the information of why it works. And so there's that's built in. And while we're on the subject of AI, so there's a lot of integrations that we've been adding for the AI, like the new kind of leverages that you can have with AI. And so we have, for instance, like these AI agents. I don't have the audio on because I get a lot of echo, but you can interact with an agent and they could role play basically like it could be a doctor or a patient, and you can prompt it to behave in a certain way, and it really adheres very well to that prompt. And you could use also offline tools now like DeepSeek or Gemma or Llama so that you could run this with no data collection, no need for any kind of account, with no tokens. And so that's also an option, which is somewhat valuable for research, because this also works with OpenAI and Gemini and Anthropic. But if you're using something like DeepSeek or Gemma, then you could completely offline be able to run an experiment and not be saving or collecting any data. And we can do data analysis with AI. So that's also like taking all of the data that you've brought in and be able to analyze what the patterns are using AI. And then I think I also shared with you some of these AI content generation. You can also generate things like audio using ElevenLabs. So if you want a certain ambient audio or a type of audio event or text to speech, that's also available. So there's a lot, and this is constantly growing. But I guess in the interest of time, I mean, that's a very quick overview, and we can have any follow-up questions after that. And I will hand it back to Dan at this point. Back to sharing.
Awesome. Thanks, Seda. I know I blew past my limit, so just make sure I'm sharing the right screen right now. Yep. Okay. So yeah, I know we're coming up on the end of the hour here. We're gonna just talk for another 3 or 4 minutes. We'd love to get to any questions that you have. So please, we haven't gotten too many questions. So if there's any questions, please submit them now. But basically, I mean, I alluded to the need. I think beyond the hardware, beyond the software, these sort of softer costs are where you really kind of need to think about budgeting. So this is just an example of, this could be a projection VR or a Prism system. This is a pretty typical facilities job, and depending on where you are and the cost of contractors, this can be a little pricey, but it's in this case, it was just a regular room. If you were just doing a corner setup, all you'd have to do is smooth out those 2 walls. So that's why corners are pretty cost effective on the facilities side as well. But to get that really nice wraparound effect, a lot of times folks are building, a custom, what we call a floating wall. So it gives you this really cool 3-sided experience. This is kind of a picture from the outside looking in to give you an idea of what that looks like. So facilities in general, I mean, just having power, data, power in the ceilings if you've got projectors. This is stuff that Worldviz, we do every day. We'll walk you through. We work with your facilities team. We provide schematics, detailed plans for where power needs to go, where data needs to go, what level finish, and what type of paint to use. So if you're working on a project, this is definitely something that we can help you with. And it's really kind of part of the service that we provide in general. On the personnel side, I'm not going to dive too much into this, but we do recommend, if you have one of these more sophisticated labs or you're planning on building your own VR content, at least having a dedicated manager for your lab, especially a large scale projection system. Having a tech who really is responsible for that space and kind of helping folks use it and really knows and owns that space is really just going to help everyday users, right? These aren't exactly, they're not Apple TV simple to use. It's not total rocket science, but it also is definitely more complex technology than I think we're used to in our world of like super easy consumer touchscreens and things like that. So definitely having a person who knows their way around is definitely recommended. Installation, this can really depend. A lot of the simpler systems are actually, just out of the box, ready to rock. So, if you're just getting a headset-based system, you don't even need an installation. But for projection systems, for something like the classroom that we showed you, you might be looking at like 2 or 3 people on site for like 3 or 4 days. And those budgets can be $10,000 to $20,000 if you're going for a huge facility build, right? Training, again, this is something we offer on-site training. we also offer really cost-effective remote training. So, you know, you can get a half-day training for not very much. I think it's like $1,600 to have a dedicated, you know, personalized half-day training from Worldviz. So if you're interested in getting that service, you know, that's something that we provide. But then we also offer on-site, you know, full seminars. So we can come out, fly out to your school, you know, train your staff on how to use and leverage VR. So that's something that we do quite a bit. Support, you know, apologies again for the breakneck pace here, but just trying to get through the last few kind of crucial topics. Support is something, you know, most of our systems come with a year of support. Support kind of includes warranty. General rule of thumb is it's about 10% of the system cost per year for support and warranty, and that's your troubleshooting, your development related questions, and your warranty, right? So there's lower cost options if you're just looking to get support, troubleshooting and software support, maintenance upgrades, things like that. But if you want the full system with warranty, you should be budgeting around 10% per year. VR application development considerations. So I don't even think we're going to really touch on this topic right now too much because Sato kind of showed you a little bit more in depth what that looks like. But in general, you know, there's two ways. Either you build it in-house or you hire an outside studio. Hiring an outside studio, I mean, you know, you're typically looking at a minimum investment of about $30,000 to build a VR application, right? We build VR apps for, you know, the National Institute of Health, for Stanford, UC Davis, University of Houston. A lot of the projects that we build are in the like $50,000 to $100,000 range. And that means they take 6 to 12 months. It's an entire team of artists, programmers, in-house scientists. Basically, it's a pretty involved production. However, we do offer a much lower cost kind of hourly based development assistance and consulting model. And that also works for a lot of folks. I mean, you know, Sato showed you all of the different VR sample scripts that we have. In a lot of cases, you know, with just a few hours of consulting or training, we can help you customize one of those scripts to meet your needs. So that drops the cost significantly. But if you really wanted to just like have a full soup to nuts application build, you know, you're looking at a pretty significant investment for hiring a studio to do that. So those are two options. There's the kind of easy hourly low cost way, and then the high investment, you know, full service way. So yeah, graphics again, something, you know, you need your 3D environment. Sato showed some cool ways to get graphics off the internet. Programming, Worldviz uses Python, which is very popular in the scientific community. Unity is a C#, and Unreal is C++. So, you know, it's kind of different programming resources that you'd be leveraging. Python works really well for even when you're using like chat-based development too, which Sato touched on. So there's definitely, it depends on what you have available to you, but you'll also need some programming as well. So this again is just kind of reiterating what I was saying about hiring a studio. You know, typically it's a pretty significant investment if you want somebody to build something soup to nuts for you. But we do offer these kind of hourly consulting services as well. So finally, I know we're a few minutes over here, but just to kind of wrap it all up with a bow, let's look at some typical VR budgets. This is like if we walked into, you know, Best Buy today and said, I want to walk out of here with a VR lab and I want to walk out of here for less than $1,500, you could do that for sure. You know, the Quest 3S is $300. A pre-configured gaming laptop these days, you know, a decent one with a 4060 can be just $1,000. And you know, we use the Predators, but there's a whole bunch. These are great setups, right? This, if you just go and DIY it yourself, you can get set up for a really low cost and have something that works, you know, remarkably well for the money. Then you leverage free and open source software. We have a free version of Vizard that a lot of folks use for their experiments. Yeah, so that's your low cost version. Now we're talking about like the middle range. So this is if you were to have Worldviz or another professional company build you a single user headset system, right? So we're talking about eye tracking, all the software supports, remote training, shipping the system out there, pre-configuring everything for you. And that, depending on, it really, we get a little bit into the world of like which headset, which computer, but our standard system for this is about 18K. We have lower cost systems that use lower cost laptops, and then we have higher end systems that use higher cost desktops, right? But you're looking at between $12,000 and $20,000 depending on which configuration. Again, this comes with all the software, hardware you need, typically with remote training and a year of support. So that's your all-in cost for just getting a Worldviz backed research system in place. We do a lot of multi-user systems as well. So if you wanted 2 of these, just double the cost. And then in the world of projection VR and Prism, these systems, I really think that if you're budgeting for something like this, it's safe to start at $75,000. But depending on what you're building, you might want to budget more than that. What we do for basically all of our customers is we provide a customized quote. We provide drawings that'll show you how the system will fit in. We'll provide a letter of support. Basically, we provide all of the, we'll provide even links to relevant publications that used our technology. So what we really try to do is make you as successful as possible for your grant application, right? And that involves an accurate quote. So, and the only way to really get an accurate quote with these projection systems oftentimes is to get an idea of the room that it's going to go in. So this is a Dayton University. Their space was kind of specially built to accommodate this system. But a full-blown lab like this has multiple headsets as well. So there's you can barely see it in the corner there, but there's VR headsets with eye tracking. There's this large-scale projection screen. You're looking at, with installation and support and everything, a system like this can easily be around $200,000 all in, right? But on the lower end of things, you can get like a 2 or 3-sided Prism or projection VR system for between like $75,000 and $100,000, depending on the configuration, right? So it's not always these huge, crazy like $200,000, $300,000 budgets, but in general, when you're working with projection VR, you are working in a totally different class than the headset-based systems. So that's just what you have to keep in mind. So if you're interested in getting a facility like this built, we're more than happy to provide all the documentation and resources that we can to help you be successful. So yeah, I think that's the conclusion of how to budget for your VR lab. I'm trying to see if we got any other questions. I did catch this one, which was what was the ballpark range for Prism, and hopefully I just answered that. Between $75,000 and $100,000 for the typical 3-sided systems that we're looking at here. It just kind of depends on your configuration, right? But that's a safe place to start. That's just for the hardware, right? We're not necessarily accounting for all of the facilities considerations. So internally, it depends on what state you're in and who you're working with. But building a drywall like this can be $2,000 or $3,000, or it could be like $15,000 to $20,000, right? So that's something to keep in mind as well. So Matthias, did you want to?
Yeah, I just wanted to join to the tail end of it, and obviously say thanks for participating. It took us 10 minutes more than we were planning for this webinar. And as a last slide here and the last point, you might have noticed when Dan talked through that we obviously have years of experience helping people configure and budget and actually get approved for their budget for VR labs. And if you want to do that, really, I encourage you to just reach out and pull us into the process, because we're we have the materials, we can help, and we can make sure that your budget is correct and also guide you on a path that leads to success out of our experience, right? Obviously can't do the research for you, but we can definitely help guide things in the right direction and make sure you're not going down rabbit holes you don't have to. Anyway, thanks for participating, I just wanted to say. And yeah, we had a whole bunch of people hang in there another 10 minutes. It's great.
Yeah, thank you, everybody. I appreciate the patience. Lost the distinction between prism and three-wall systems. Okay, so just a little bit more Q&A here. This is the last question I'll answer, which is, so basically, and this is where things get a little complex, but going back to different types of configurations. So projection VR is 3D, prism is 2D, but basically you can have any number of walls, right? So it's just a matter of how many projectors and how many sides you have. Oh yeah, go ahead, Matthias.
What's the question, Dan? Sorry.
It says, I lost the distinction between prism and three-wall systems, but I think, just trying to see if, yeah, I think that's our last question though. So yeah, and some really great thanks are coming through in the chat as well. So if y'all haven't subscribed or visited our YouTube or our website, highly recommend you to do that. And yeah, we'd love to hear your feedback on this webinar as well. Yeah, any other parting thoughts, Cedar or Matthias?
Well, there's a little feedback kind of form coming up when we end this webinar. Please let us know what you're thinking and what we can do better next time. We're very happy to take your comments and incorporate for the next one. Thanks a lot.
Yeah, thanks everybody. Now, how do we close this?
Thank you.
Awesome. Thanks, Cedar. Thanks, Matthias. And thanks, everybody.